is the study guide for the final test for Chapter 1, Section 1.2, which you can find the summary on page 42. The major themes, I'll let you go ahead and read the summary yourself. The major themes on the test from this part of the chapter are understanding the differences between the different types of errors really well, because questions on the test will make it very tricky. The different types of errors are validity, bias, reliability, and accuracy. I don't see accuracy up here in the summary, but make sure you read over these. You can look up accuracy in the back of the book to find out what page it's on, so you can read that also. But make sure you really understand, if something is biased, it's going to have the same error every time. If I step on the scale and it's constantly 3 pounds overweight, it's always the same 3 pounds overweight, that's going to be an error of bias, okay? Reliability is going to be that you get a different error each time, so that is obviously not reliable, okay? You can improve reliability by averaging the results, and that's going to become very important on the test, so make sure you realize that. The validity error, what it's talking about is it a valid way to measure what you're measuring? So is it a valid way to measure how smart you are by finding the volume of your skull? Do people with bigger skulls have higher IQs? I don't think that that's a very valid way to measure how smart you are. Okay, so those are the different types of things. Here I just did averages improve reliability. There will definitely be a question on the test about that. And also you need to know that rates are going to be a better way of looking at numbers than counts, especially if the base count is different, if you're comparing different years or different classes, things like that. You have to find the rate so you understand which one is better. Questions from the review packet are here. I'll be going over each of those. And at the end, we'll do a short response practice question number 1.75 on page 61. Matches up really well with one of the short response questions that I saw on the test. All right, so let's get started with these questions that are going to be match up with what's on the test, and that is number 3 down here. A psychologist says that the scores on a test for authoritarian personality can't be trusted because the test counts religious beliefs as authoritarian. The psychologist is attacking the tests, and then here it gives you the 4 different types of errors. Is it attacking the validity, the reliability, the bias, or the accuracy? So validity, what it's asking is it a valid way to test for authoritarian personality by looking at your religious beliefs? Reliability would be looking at if somebody's going to give a different answer all the time, or maybe it's worded in such a way that a person would rather not answer a certain way. Bias, is it the same error happening over and over again? And accuracy, is it an accurate way to, is the measure going to be accurate when they count it up? In this one, I picked validity as the correct answer, because what it's looking for is, it's saying that it's not a valid way to test for an authoritarian personality by looking at the religious belief. It could be, it might not be, that would be an entirely different observational or type of study, but in this case it's attacking the validity of asking that question. In one of the first attempts to discover the speed of light, this is number 4, Simon Newcomb in 1882 made 66 measurements of the time light takes to travel between the Washington Monument and his laboratory on the Potomac River. Why did Newcomb repeat his measurement 66 times and then take the average of the 66 as his final result? And this is going to come back to exactly what I was talking about on the summary sheet. The average of several measurements is more reliable than a single measurement. Make sure you realize that for the test, okay? Number 5, Professor Kanu has developed a new college entrance test. Any such test must have several versions because some people take the test more than once. Unfortunately, it turns out that the same person often gets very different scores depending on which version of the test is offered. This test suffers from, that's going to be low reliability because they get different scores for the different tests. They're not constantly getting the same different score. That would be biased. But they're constantly getting different scores on the test. So that test is not reliable. Question 6. You might try to measure how rich a person is by looking at the car they drive. In fact, driving a fancy car has little to do with income. In statistical terms, measuring income by car model is not valid. It's not a valid way to measure it. Okay. Let's see, number 7. During a visit to the doctor, you are weighed on a very accurate scale. You are weighed 5 times and the 5 readings are essentially the same. When being weighed, you are wearing all of your clothes and a pair of hiking boots. As a measure of your weight without clothes, the reading on the scale is, well, that's obviously that hiking boots and the clothes are going to add weight to you. So it's going to be the same weight each time. That error is going to be biased. So this is obviously biased. It's going to be D or E. So D says it's biased and unreliable, and E says it's biased and reliable. And it's going to be E because it is reliable. It's giving you the same number each time. However, of your regular weight, it's going to be over however much your clothes and your hiking boots weigh. Number 8. Let's see. Number 8 says, which of the following statements do you think could possibly be true? A, the number of students enrolled in Ohio State University is about 2 million. That's absolutely ridiculous. There's not even 2 million people living inside the city of Denver. B, a basketball team made 110% of its free throws in a game last week. You cannot make more than 110% of the free throws, or you would have been making more free throws. It doesn't make sense. The temperature will be 195 degrees Fahrenheit tomorrow in Chicago. Well, all those people in Chicago would be cooking if that happened. More than 30 million people live in California. I can believe that for sure. California definitely has a huge amount of people, and I think one of the most states with the most electoral votes. And E, the textbook for this class weighs 250 pounds. Well, obviously it's not E, so the one here is going to be D. More than 30 million people live in California. Number 9, when I set my alarm to ring at 6:30, it rings 10 minutes late every day. My alarm clock is biased. It is the same error every day. That alarm clock is biased. Let's see. Also, number 11, we'll skip 10. That's for 1.3. But number 11, a company used to give IQ tests to all job applicants. This is now illegal because IQ is not related to the performance of workers in the company's jobs. That is, IQ is a measure of future performance on the job is invalid. It is not a valid way to measure IQ. Obviously, you're not going to get a good answer. Number 12, an ad for, we'll skip number 12. That'll be for 1.3. Number 13, IQ tests are intended to measure general problem-solving ability, which is what we mean by intelligence. Some experts think IQ tests measure not intelligence, but how much education and how much exposure to middle-class culture you have. These experts say that IQ tests are A is biased, B is not valid, C not reliable, D highly variable, or E subject to a non-sampling error. Again, it's going to be not valid. It is not a valid way to measure your intelligence. It's saying it's a way to only measure how much education and exposure to culture that you have. Number 14, you measure the age in years, the weight in pounds, and marital status, single, married, divorced, or widowed, of 1,400 women. How many variables did you measure? Well, you measured years, pounds, and marital status. So that is 3 variables. The individual there would be the women, but you only had 3 variables. Oops. Okay. Number 15 is for 1.3, 16 also. 17, let's see, my numbers might be mixed up here. 17 is this one here with the states. That's also in 1.3. Oh, I see, it's over here. That's 17 here. So we're going to go straight to 18 still for 1.2. Again, it's hard to measure intelligence. We know that. Let's do it the easy way. Measure height in inches and call the result intelligence. Not only is this method easy, it gives the same number every time we repeat the measurement on the same person. Measuring intelligence this way is highly reliable but not valid. It's reliable because they get the same measurement each time, so it's definitely reliable, but obviously not valid. That's a crazy way to measure intelligence. Number 19, a measurement process that does not systematically overstate or understate the true value of the quantity being measured is unbiased, right? It says each time, systematically, if you remember from that video we watched, bias and systematic errors are the same. So if it does not systematically overstate or understate the true value of the quantity, it is definitely unbiased. Let's see, the rest of this page is for 1.3. 1.3. Oh, all right, number 30 is for 1.2. A researcher creates a machine that will measure the total electrical activity in a human brain over a short period of time. She claims this measures the intelligence. They're really concerned about intelligence here. She claims that this measures the intelligence of the brain's owner. A psychologist says that's not true because the amount of electrical activity isn't related to ability to solve problems. The psychologist is claiming the electrical activity as a measure of intelligence is invalid again because it's not measuring the ability to solve problems. It's measuring the amount of electrical activity, and those two aren't related. So that is definitely invalid. Okay, so I get the feeling from these questions that the test bank is asking you, they really want you to know when something is invalid. Number 31, Professor Ziegenfuss of the Geology Department has ordered a new instrument which is supposed to measure the iron content of iron ore. After the instrument arrives, he uses it to measure the iron content of 5 test samples of ore, all of which are known to be exactly 16%. The numbers given by the machine on these 5 test samples are 5%, 3%, 28%, 16%, and 25%. Based on these measurements, one can conclude that the new instrument is